In this video, we're going to work a couple of more advanced absolute value inequalities. And I wanted to go ahead and throw some problems in that involved absolute values with variables in the denominator. So here you can see we have a rational expression inside of an absolute value. And then in the next problem, it's still kind of like a rational expression, but the absolute values are broken up. There's one in the numerator, one in the denominator. So let's take a look at these problems. So the general approach to how you solve these is exactly the same as the general approach that we've used to solve all of the absolute value inequalities that we've worked. And as I've mentioned, the mechanics of how we solve absolute value inequalities is the exact same as the mechanics that we use to solve absolute value equations, except in the different intervals we're solving equations instead of inequalities and making sure that the solution to the equation is in the interval that we're working in. So it's the same, it's all the same mechanics. So, all right, so if we're using the exact same approach that we used to solve all of the previous absolute value inequalities, then we know that the first step is to simplify the inequality as much as possible. Here we can't simplify this anymore. Then the next step is go to every single absolute value, look at the expression inside of it, and identify all of the crossover points, or the points where the x values where that expression changes sign. Now, we've up to this point, we've had polynomials inside the absolute values, which I told you that polynomials only change signs when they cross over 0. So you just need to solve for when each polynomial was equal to 0. But as I also mentioned, other expressions like a rational expression, it's not necessarily just when it equals 0. It could be where, here it changes sign when you cross over x is equal to 1. Well, this is not equal to 0 at x is equal to 1. This is undefined at x is equal to 1. So, but don't get bogged down with or worried about, well, how do I find all of the points where any kind of expression changes signs? You'll learn that in depth in calculus for all types of expressions. Okay, so I'm just going to go ahead and tell you where this changes signs. This changes signs at x is equal to 2/5, and this changes signs at x is equal to 1. Okay, so let's assume that you were comfortable finding where this changes, the x values where this changes signs. You found that it changes signs at x is equal to 2/5 and at x is equal to 1. So what we do is we draw a number line and we plot these 2 points. X is equal to, or x is equal to 2, not 5/2, 2/5. I think I said 5/2. So x is equal to 2/5 and x is equal to 1. Okay, and then we draw these vertical lines so we can see the different regions we need to analyze. Okay, now since we know this only changes signs, this expression across these points, all we need to do is just plug in some x value over here, and over here to see what the sign is in that region. So, okay, let's plug in x is equal to 0. That's easy. So you've got -1 in the denominator and -2 in the numerator. So it's going to be positive over here. Okay, now let's plug in 2. Let's plug in 2. So 2 minus 1 is 1. 5 times 2 is 10. 10 minus 2 is 8. So it's going to be positive over here. So it should be negative in the middle. So let's see. Let's do 3/5. So 3/5 minus 5 over 5 is going to be minus 2 over 5. 3/5 times 5 is 3. 3 minus 2 is 1. So it's going to be negative in the middle. Okay. Now, also remember, we want to make sure we test every single point throughout all of the real numbers. Okay. So, but we can already see what that like 1 is not going to be a solution because the expression doesn't even exist when x is equal to 1. You can't divide by 0, or even like 0 divided by 0. Even if the numerator was 0, that wouldn't matter either. Like if the numerator and if the denominator was 0, but the numerator happened to be 0 as well, that doesn't mean that, okay, well, we can evaluate 0 over 0. No, the denominator of a fraction can never be 0. So we know that there's not going to be any solution at 1. Okay, and if we wanted to, we could just plug in 2/5 and see if it's a solution or not. Or we can just figure that out throughout the process. So like if you wanted to, you could just plug in all the boundary points and see if there's solutions. I mean, just note that. Like if you were some supercomputer, you could just plug in all the infinite values over the entire, just keep plugging all of them in and see which ones are the solutions. I mean, there's an infinite number of values, but just saying, like, don't forget the fundamental meaning of what a solution to an equation or an inequality is. You're just plugging in a value and seeing if it's a solution or not. Seeing if you simplify the left side and the right side, does the inequality or equation, is it satisfied? So, all right, let's start with, we're not going to say x is greater than or equal to 1. There's no need to say equal to 1. We're just going to start with x is greater than 1. Okay, so this is positive. This expression here is positive in that region, so we just remove the absolute value. Okay, now we just need to solve this inequality. And now, but this is not a linear inequality, and so as I mentioned, we aren't going to be able to. The linear inequalities are really nice because they're so simple. We can just apply the properties of inequality and simplify until we get all the way down to like x is greater than or whatever, some number. But in general, that's not how you're going to be able to solve inequalities. In general, we're going to have to bring everything to one side, with the other side of the inequality being equal to 0. So we can subtract 1 from both sides. Then we're going to have to do the analysis that we're going to learn in calculus in detail, and find all of the intervals of all the intervals where this is positive, negative, or equal to 0, this expression. And then we can read off, okay, where is this expression greater than 0? And that's going to be the solutions. That's the process. So let's do this. Let's write 1 as x minus 1 over x minus 1. Okay, so you have 5x minus 2, and then minus x plus 1 over x minus 1. Okay, you have 4x minus 1 over x minus 1. Okay, so you would do your analysis on this, and I'm not going to go into how to do that in this video. I'm just going to tell you where, what you would do is you would figure out that, okay, this is, so, okay, at x is equal to 1/4, and at x is equal to 1, this changes signs. You've got positive, negative, positive. Okay, and it equals 0 at 1/4. So the solutions here are, the solutions to this inequality here, which is the solutions to the main inequality, are x is less than 1/4, or x is greater than 1. All right, now, but we're not done, because where do these cross over? We're only analyzing when x is greater than 1. Well, x is less than 1/4. That's not within the region. So it's x is greater than 1. So x is greater than 1. These are all solutions to this inequality. Okay. Next, let's do x is less than 1 and greater than or equal to 2/5. Okay, so what happens there? At 2/5, we're equal to, oh no, okay, well, let's do just less than 2, or just x is greater than 2/5, because in that case, this expression is always going to be negative. I like to save, if this expression could be 0, I save that for the case where the expression is going to be positive or 0. So this expression, with this interval, this expression is always going to be negative. So we do this. Let's multiply both sides by -1. Okay, let's add 1 to both sides. So let's do this. Okay, 5x plus x is 6x. Minus 2 minus 1 is -3. Okay. Here it's going to be a very similar pattern in that we're going to have we're going to have, so this is going to be 3 divided by 6 is 1/2, and then we'll have 1, and then we'll do positive, negative, positive, but it doesn't exist here. So at 1, so we've got x is less than 1 and then greater than 1/2. Okay, but now let's compare that to this. Where do they cross over? So 2/5 and 1/2. Well, what is 2/5? That's less than 1/2, right? Or no. Let's see. 4/10, that is less than 1/2. So they're going to cross over here. Here. So, okay, let me create some room here. So here's more solutions. Okay. All right, so we've done this region, we've done this region. Now let's do x is less than or equal to 2/5, and x is, that's it. That's it. That'll be everything over here. So this is going to be positive or 0. Now, but we've already solved this inequality, right? The case where this was we just removed the absolute value and solved it. We've already solved this. So we don't have to, are we done? We don't have to do anything? No. We don't have to solve the inequality again, but we do have to come look at the answers. Here was the solutions and compare them to this new interval. Okay, so I erased this. What was it? When was this greater than 0? This was greater than 0 for x is greater than 1 or x is less than 1/4. Okay, so, but where do these cross over? Okay, 2/5 and 1/4. 2/5 and 1/4 are, 1/4 is 0.25, 2/5 is 0.4. 1/4 is 0.25, 2/5 is 0.4. So it's going to be x is less than 1/4 is where they cross over, right? So, okay, x is less than 1/4. There we go. And so now that's everything. Now we just need to condense this down as much as we can into a big OR, with a big OR, all of these. So, all right, we've got, let's see, 0. Okay, let me bring this. We've got, so 0 and 1 and 1/2 and 1/4. Okay, so x is greater than 1. X is less than 1, greater than 1/2. X is less than 1/4. So we can see that we've got x is greater than 1/2, not equal to 1/2, but x is not equal to 1, and then x is less than 1/4. So if we could put that in interval notation, let's see. We've got negative infinity to 1/4, not including 1/4, in union with, let's see, 1/2 to 1, not including 1, in union with 1 to infinity. There we go. That's the solutions. Okay, so you might look at this and think, man, well, what do we do here? Same general process. Same process. We just go to, here there's 2 absolute values. We go to every single absolute value in the entire inequality, and it's the same mechanics with an absolute value equation, and you just find all the crossover points. Now, just assume that you're an expert at finding points where any kind of expression changes from positive to negative. Assume you're an expert at that. If you assume that, and you're going to be when you're done with calculus, this shouldn't intimidate you. Okay, I'm telling you that when you have a polynomial expression, it's just fine where x equals 0. So we've got x is equal to 9/2 and x is equal to -3. So let's see, that's about, here's about 9/2, here's about -3. And that's it. For all of the absolute values in the entire equation, those are all of the crossover points. If there's multiple crossover points in one expression, like if this was a fourth order polynomial or something, mark all of them off. All right. So now we see we've got these three separate regions. We just need to analyze this because these are the crossover points, and we'll be able to identify expressions as 100% negative or positive, certain absolute values as 100% negative or positive in these different regions. The whole purpose of that is we'll be able to simplify the absolute values, remove them, and then we can solve inequalities. That's the whole point. So we want to go in each of these regions and solve the resulting inequalities. So if x is greater than or equal to 9/2, this is going to be positive or 0, and this is always going to be positive. So we can do this. 2x minus 9 over x plus 3 is less than or equal to 1. Okay, so, but again, here, we're not going to just multiply both sides by x plus 3. In general, with an absolute value, or not an absolute value, in general with just an inequality, the process is bring everything to one side and then find where the expression with the other side equals 0, and then find the intervals of the positive and negative intervals of the expression. So subtracting 1 from both sides, let's write 1 as x plus 3 over x plus 3. Okay, now we've got, let's see, 2x minus 9 minus x minus 3, which is x minus 12. So x minus 12 over x plus 3. Okay, so now let's, I'm not going to show you how to do this, but I'm just going to tell you where this is positive and negative, the intervals. So we've got, let's see, minus 3 and 12 are the crossover points. It's going to be positive over here, negative over here, positive over here. And it doesn't exist at minus 3, and it's 0 at 12. So where is this less than or equal to 0? That's going to be less than or equal to 12, greater than 3. Great. But that needs to, where does this cross over with this? Because this is the only, what we're analyzing the inequality for, these values. So where is x greater than or equal to 9/2? So 9/2 is what? That's like 4 point something. So we can see it's going to be, x is going to be greater than or equal to 9/2, less than or equal to 12. These are all solutions. All right. Now, what about this region? So we've got x is less than or equal to 9/2. That means this could be 0. Well, okay, no, we don't want to. We already did equal to 9/2. So less than 9/2. And then greater than negative 3. But not equal to negative 3. We can't do that. We can't be dividing by 0. So, okay, in that case, this is going to be always negative. So 2x minus 9 is always going to be negative. And then this down here is going to be always positive. So x plus 3 less than or equal to 1. So let's multiply both sides by negative 1. Flip the inequality. Now let's add 1 to both sides. We'll write that as x plus 3 over x plus 3. Okay, so 2x minus 9 plus x plus 3. So we're going to get 3x minus 6 over x plus 3. Okay, now we could write this as x minus 3. 3 times x minus 3 over x plus 3, but that won't simplify. So, okay. So this is going to be, we'll have, once again, it'll be at minus 3. And then we've got 2. And it's going to be positive, negative, positive. So, and then it doesn't exist at -3, it's 0 at 2. So where is this greater than or equal to 0? It is greater than or equal to 0 when x is greater than or equal to 2, or when x is less than -3. All right, now where does that cross over with this? Well, okay. Less than -3, there's no crossover. So it's just, we've got x is less than 9/2. This is like 4.5, I think. And then x is greater than or equal to 2. So there's more solutions. Okay, now I'm going to, let me leave this up here because we're probably not going to have to solve another inequality. I don't think we will. So what about when x is less than -3? In that case, this is always going to be negative, and this is always going to be negative. So we would simplify that by doing this, right? Well, the negatives cancel, so what are we left with? All right, but it doesn't mean we don't have to analyze this region. It just means we don't have to solve this again because we already solved this inequality. It's this over here. It's this. But we have to analyze it again because now we're not comparing this to this. We're comparing this to this. So, okay, x is less than -3. Where does that cross over with this? Well, it doesn't. It doesn't. So there's no solutions here. All right, so those are our two solutions. We just need to condense that down with an or between those two inequalities. So, okay, let's see. We've got, all right, 0. Let me put the 0 over here. We've got 0, 12, 9/2 is like 4.5. So 6, 9/2. We've got a 2 here. All right, so x is less than or equal to 12, greater than or equal to 9/2. X is greater than or equal to 2, less than 9/2. Okay, well that matches up like this. X is less than or equal to 12, greater than or equal to 2. That's the solution to this inequality.